start.
Maybe you can sit in front since the
It's all going to be late.
yes.
There are other people coming, right? But they are late.
I think so. I
Yeah.
think so because of rain.
Rain. Okay. So shall I start or
Sorry.
go ahead? Okay. Good afternoon, everybody. Had a good lunch.
Yes.
Okay, so that's good. So before I proceed, right? Okay, just want to ask you some questions. Okay, with regards to oils, right? Okay, so can you take a look at this, please? So tell me, okay, have a look at this, okay, and tell me which of these oils you think is the heaviest. That's the heaviest. So which one do you think is the heaviest? C is the heaviest, okay. And what about the lightest? E. So I think you're quite good, but if you don't mind, just arrange what you think is from heaviest to lightest. Go ahead. Okay, so this is what you think is heaviest to lightest. No, it's not too bad. Okay, I'll just switch this and this. This is yes, the heaviest. Okay, and this is the lightest. Okay, so color does give you an indication of how heavy the oil is. The density. Okay, how heavy the oil is, or how light oil is. Okay, so take note of that. Okay, because later we will be discussing how what do you call color. Okay, tells you how heavy or light the sample is. Okay, now basically Muru is going to be helping me with this presentation. Okay, so he's got a history of oil and gas industry, so in the oil and gas industry. Okay, so that's why I asked him to help me. Okay, but anyway, we had a long day. We did not have lunch. Okay, he also didn't have lunch. Okay, so crude oil is energy, right? So we can drink crude oil, right? Why cannot? It's oil, but I'm going to show you something. I'm going to drink it. Okay. Huh? No, this is not petroleum. This is like a oil with some water. So that's why it's got this color. Okay, so he's going to have something. I'm going to have something like
Yeah,
that.
that.
Yeah. Okay, you have that. I'll have this. Yeah. We can drink crude oil.
No sugar, that's fine.
There's no sugar. Huh? It's not no sugar. Okay. Anyway, just for your information, okay, we just inform you. All these are actually coloring additives, okay, but they're made to look like crude oils. Okay, this is actually coffee. Okay, this is coffee. Okay, so just for your information, lunch. Okay, okay. So we'll continue. Okay, so basically two modules in this training. Okay, the first module is basically introduction and what is crude oil. Okay, how is crude oil formed? Okay, the historical perspective of crude oil and the importance of crude oil in the global economy. Okay, the second part is the more important one. Okay, it talks about the technical aspects of crude oil, key components of crude oil, different types of crude oils, properties of different crude oils, and then we'll have a question and answer session. Okay. Please note that because this is a 1.5 session, we can't cover a lot. It's basically surface this thing. So it's difficult to cover everything about crude oils in hydrocarbons. Okay. Okay, so by the end of this course, okay, the course objectives are basically to understand the importance of crude oils, okay, understand the basics behind fossil fuel formation, okay, and understand the types and properties of crude oil, okay. Now, so who am I? I'm Devendran, okay. It's very difficult to pronounce my second name, okay. So my last name, so don't worry about that. Okay, I'm a chemist by profession. Okay, I've got 30 plus years in the oil and gas industry, and I've served companies like Kodak, Intertek, SGS. Okay, so that's why I mentioned things like SGS and so on. So for simplicity's sake, okay, just call me Devan, or you can shorten it to Dave. Okay. I remember once when I was studying in Canada, okay, they were handing out the assignments after being marked, right? And when the lecturer came to my thing, he looked at it, he froze for a while and said, I'm not going to pronounce this name. So I knew it was Milan. Okay? So, by the way, we shall continue. Okay, so what is crude oil? So crude oil is basically a fossil fuel, okay, found underneath the Earth's crust. Okay, it's also known as petroleum crude, okay, or petroleum. It ranges from yellow to black. So you saw those colors there, yellow to black. Okay, and it can range from light, very light, fluid, or very viscous. Okay, sometimes they don't move. Okay, so at room temperature they don't move. Okay, so you need to know that. Okay, it is mainly made of hydrocarbons, but you do have heteroatoms like sulfur, oxygen, nitrogen, and sometimes metals. Okay. Now, crude oil is one of the phases that you see in a reservoir. You see natural gas. You also see water. Okay. And what's a petroleum reservoir definition? It's accumulation of hydrocarbons in subsurface porous rock formations. Okay, very important, huh? Porous rock formations. Okay. And what is petroleum? So basically, petroleum is derived from the Latin word, okay, and it means rock oil, basically. Okay, and crude oil is the second most abundant liquid on Earth. Okay. Now, so a lot of people believe these oils, right, form a pool underneath the crust. Okay, and that's not true. Okay, so it's not a big pool of oil. Okay, these oils are basically contained in porous rock. Okay, now for this to happen, okay, for oil to be retained, okay, you need three things. Okay, you need to have the source rock where the kerogen is formed. Okay, you need to have the reservoir rock where the hydrocarbons move into, and you need to have a cap rock. Okay, that prevents the oil from being released to the atmosphere. Okay, we don't want it to move up. Okay, we want it to be retained in the Earth's crust. Okay, so that's the kerogen. It's waxy stuff. It's thick. Okay, it's insoluble. Okay, and how is it formed? It's formed from algae, plants, and microscopic organisms. So over time, heat, and pressure, kerogen forms crude oil and natural gas. Okay, so the two processes that are involved in the formation of crude oil. One is called diagenesis, another one is ketogenesis. Okay, so there are two steps here. Okay, one is organic matter like plants, dead plants, algae, is transformed by heat and pressure over millions of years into kerogen. Okay, and then over time, this kerogen then is what do you call layered by other layers of sediment, okay? And then what happens is it cracks and forms hydrocarbons. Maybe we'll stop here for a while, and maybe we'll ask him the same question that we asked this now, okay? So, can you take, before we continue, right, okay? I'm sorry, you must have been caught in the traffic jam, right? Okay, no problem. It's a pain. Whenever there's a heavy rain, right? Okay.
Your name, sir?
Kiran. Okay. What's your background, by the way? Sorry?
Volume chemical.
Oil chemical. Okay. So, but you're a chemist by profession.
Did my degree in business, business,
Okay.
but now it's
Logistics. Okay. So, she went through this whole process now. So we are asking you this question. Okay. Okay. Crude oils, right? Okay. They actually range from colors from light yellow to all the way dark. Okay. So if I were to ask you, okay, to arrange these crude oils, okay, from heavy to light, okay, highest density to lightest density, okay, how would you arrange them?
good, yes, I'm not sure.
No problems, no problems. So, which way?
So this is the
Heaviest,
most heaviest.
most heaviest. Okay, so usually color is an indication whether it's heavy or light. Okay, so this will be most likely the second most lightest. This is probably going to be in the middle. Okay, this is heaviest. Okay, so the darker it is, actually the heavier it is. But in this case, okay, it's a bit. You can see it's a bit. There's something inside there. Okay, so just for your information, that's the thing. But in reality, these are just the colors of crude oil. Okay, this is actually not crude oil. Okay, this is actually the coloring for your food. Okay, but it looks similar. It does look like crude oil. Yes. Okay. Okay. So and this is actually coffee. Okay.
This is the copy of. I just had to see this one.
You missed the interesting part. Okay. Okay. So maybe I'll just for your benefit. Okay. I'll just go one, two slides before. Okay. So basically, petroleum reservoirs. Okay. For oil to be present to be present, right? Okay. You need three things. Okay. One is you need the source rock. Okay. Where kerogen is formed. Okay. Source rock. Okay. So where kerogen is formed. Okay. Kerogen is basically all these dead plankton, dead algae, dead plants. Okay. Microorganisms that have died, and over time they have gone settled at the bottom of the sea. Okay. And then you have layers of sediment that cover it. Okay. So with time, pressure, temperature, it turns to kerogen. Okay. So you need the source rock. That's one. Number two, you need to have a reservoir rock. Reservoir rock are rocks that have holes, like pores. Okay. And what happens is with time, the kerogen will then break down and form oil or gas, and they'll travel and stay in this reservoir rock. Okay, that's why they say they're porous and permeable. Okay, and then you'll need a layer of rock that stops this oil from escaping to the top. Because if it escapes, you don't get it, right? Okay, and that's called the cat rock. Okay, so a lot of people who are not in the okay, they think that actually when you dig a hole, okay, you actually see pools of oil there. It's not the case. Okay, they're all in rocks. Okay. Now, so kerosene is basically the precursor of crude oil. Okay, it is that's the color. Okay, that's how it looks like. Okay, and basically it's formed after, as I mentioned, dead plants and so on, subjected to high pressure, high temperature. Over years, millions of years. Okay, not 1-2 years. So you cannot take some algae and you stay and then put it in, and then maybe in 2 years time you'll see oil. You won't see that. Okay, and then of course over time, heat and pressure, kerosene then forms into crude oil. Okay, and natural gas. Okay. The transformation, there are two processes. Okay, one is diagenesis, the other one is ketogenesis. Okay, so the first step is the kerosene part. The second part is when kerosene breaks down into oil and natural gas, and that's cracking. Okay, now I don't know whether you heard the word cracking. Okay, cracking means you got a large molecule, it cracks into a smaller molecule. Okay. Did you learn chemistry in this thing? Okay, so basically you have very large molecules. Okay, if you put pressure and temperature, it will break. Okay, and that's what you call cracking. Okay, and this is basically a diagram. Okay, from that's the source. Okay, and that's basically how the process occurs. Okay, do you have any questions about this? Any more questions? Okay. So, what was crude oil used for? When did they start using crude oil? Okay. So, apparently, as early as 4000 BC, okay, crude oil, not crude oil actually, but the bitumen or asphalt, okay, the heavy products of crude oil was used for waterproofing and embalming. Okay. So that means if you are on ship, okay, you want to waterproof it, you use that. Okay, asphalt is thicker. Okay, okay. In 6600 BC, the Chinese apparently used it to as a light source. Okay, and it continued like this until in 1859. Okay, when Colonel Edwin Drake, okay, drilled the first successful oil well. Okay, and one of the things, refined products that you get from crude oil is kerosene. Okay, and kerosene is used as a light source. Burning of kerosene, you can get light. Okay. Now, of course, then the next thing was the invention of the internal combustion engine. Okay, and from the internal combustion engine, you got the Ford Model T. You heard about the Ford Model T, right? The first car, right? Okay, and because you got the Ford Model T, okay, then of course it was easy for people to use automobiles, and as a result of that, there was an increase of gasoline consumption, and therefore increase in oil exploration, production, and refining. Okay. Currently, crude oil is not only a fuel source, but it's also used in fertilizers, okay, chemicals, okay, plastics, okay. Do you know that plastics were made of crude oil? Okay, so, and even pharmaceuticals, okay, you'll be surprised, okay. Okay, so how do you extract crude oil? Okay, how do you extract it? You basically extract it using an oil rig. Okay, it can be land, overseas. In most cases, it's overseas, but not necessarily. Okay, in Saudi Arabia, it basically US, there are a lot of land rigs. Okay, so basically the rig drills in until it reaches the oil reservoir. Okay, but before they do all of these things, they would have done a lot of studies, geological studies before they do this. Okay, they need to find the oil first. Okay, and of course there are many ways to produce the oil. Okay, producing the oil is basically making sure the oil comes to the top so that you can use the oil. Okay, so the many ways of producing the oil. One of the ways is because letting the natural pressure to push the oil up. Okay, and sometimes what they use is they use artificial gas lift or a pump. Okay, so they'll use a pump to pump the oil up, or they'll use gas to pump it up. Okay, these are the types of oil rigs. Okay, just for your information. Okay. Anybody know what a FPS is? Guru?
Floating processing.
Production storage.
Production storage.
Yes. Okay. And TLT?
Can't remember that exactly.
Anybody? What's a TLT? So it's called a tension lift platform. Okay? Now, why is crude oil important? Without crude oil, we can't move our cars, right? So it's of course used as a fuel. Okay, fuel not only for the automotive industry, transport industry, also planes, jet fuel. Okay, so it's a fuel. Okay, and of course it's also used for raw materials for several industries. Okay, so as a fuel, it gives it power. Okay, our light, aircon, without fuel, without what you call crude oil, right? You can't get power. Okay, heat homes. Okay, heats homes. Okay, it powers machinery. Okay, and of course it generates a lot of electricity. Yeah. Now, it's a raw material to make plastics. Okay, it is used in fertilizers and pesticides. Okay, it's used as medicines. Okay, do you know that Panadol and ibuprofen is also made from crude oil?
No.
Okay, just for your information. And asphalt, the residue that you get from a refinery, right, is used to pave your roads. Okay, now plastics. What are the plastics that you know of?
High density plastic, low density plastic.
So, give me a name. What are the common plastics that you know of?
Plastic bags, plastic bottles.
Sorry? Polyurethane. Okay, that's one. Polyethylene.
Polypropylene.
Polyethylene. Okay, polypropylene. Okay. Then PVC. Polyvinyl chloride. Okay. And then what else we have? Polystyrene. Okay, so just for your information. So how do you get plastics? So you have sections of the crude oil, okay, your vacuum gas oil, your gas oil, your residue, okay, the end portion of the refined product, right? Okay, it's not wasted, you can use it, okay? So what they do is they crack it, okay? So like I said, you have a large molecule, you crack it, okay? And the byproduct of all this cracking is ethylene propylene, okay? You can form polyethylene, you can form polypropylene, okay? Now, polystyrene is different, okay? Basically, you use the aromatics in the crude oil to form the polystyrene, okay? This is the structure of the monomer of polystyrene. You know what's monomer? Huh? Monomer is the starting product. What happens is this will then connect to another of these molecules and form polymer. Yes. Okay. Vinyl chloride is this. Okay. It's basically a ethylene missing, but you substituted the chloride, the H with the chloride. That's all. Okay. Polyetherenes are these. The feedstock for polyethylene is toluene. Okay. I'm not going to even try to pronounce this word. It's a tongue twister, just like my name. Okay. The feedstock for this is called PET. They call it short form is PET. Okay. No, PET, sir. It's PET. Okay. They use xylene as a feedstock. Okay. Now, how fertilizers? Fertilizers, you use natural gas. Okay, you do steam reforming, you form hydrogen. And then hydrogen is made to use ammonia. And from ammonia, you make urea. Okay? So that's basically the use. Okay? Now, so this is the key components of crude oil. Okay? Now, crude oil contains different types of components. Okay? And they're usually classed by aliphatics and aromatics. Aliphatics are alkanes, isoalkanes, and cycloalkanes. Aromatics are anything that contains a benzene ring. Okay? Do you remember what's a benzene ring? Do you? Yeah, okay. So benzene ring is a 6 cyclic compound, okay? But its D has a delocalized what do you call bonding. Okay, so it's denoted by this. It's actually 3 distinct, but it's denoted by this. Okay, because it's all these are basically shared by all the 6 carbon molecules. Okay, now turn your attention to this. So this is what is called an alkane. Okay, consider this as this is the carbon and this is the hydrogen. Yeah? Okay. 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 So that's an alkane. Okay, normal alkane. Okay, straight chain. We call it a straight chain hydrocarbon. Okay. This is called isoalkane. Why is it called isoalkane? Because you got the carbon and then you have the carbon as a constituent. Okay, attached to this. Okay, so it's branched. That's why they call it branch. Isoalkanes are branched. Okay. Then you have cycloalkanes. Okay, which cyclo means ring. If you see the name cyclo in front, it means it's a ring. Okay, so this is a ring. Okay, and then finally you have aromatic compounds. Okay, they only have one H on each carbon compound, carbon molecule. Okay, so they look different. Okay, so if I were to ask you, okay, which of these compounds will have the highest density? Benzene. Then second, cyclohexane. Then third, this one. Why is that? Do you know what?
It's because
Well, there are many reasons for it. Okay, and I won't go into the in-depth thing. But basically, this is a flat molecule. So you want to arrange another molecule next to it. Okay, you have intermolecular interactions, right? But you want to arrange things. It's easy to arrange things. Yeah, they can come close. Okay, so the molecular interaction can pull them closer to each other. Whereas in this one, you got all these hydrogens the same protruding with that, right? So is it easy to bring it close to each other? Not easy, right? But this is even worse. This is even worse. You want to try, this is of course
also
normal.
fragmentation is not much.
So yeah. Okay, very difficult. Okay, so that's one of the reasons, but that's not the only reason. Okay, now if I want to change something, right? If I were to add this here, is it still an aromatic compound? It's still an aromatic compound, right? Okay, because this is what's called toluene. Okay, and if I add this here, this is what's called xylene. Okay, this is paraxylene. Paraxylene means the two carbon molecules are in this position, 1 and 4. Okay, now what I got is normal alkane and I add something here. What happens?
Ethyl exit.
Okay, so what group does it belong to? Which of the subgroups does it belong to?
Iso.
Correct. Okay, because now it's not a straight chain anymore. It's a branch chain. Okay? So you understand, huh? Huh? Try to. Don't worry, don't worry. Okay? You can always sit down with you and explain things more better. Okay, so what else is contained in crude oil? You have sulfur compounds, you have nitrogen compounds, you have oxygen compounds. Okay, they are called heteroatoms. Okay, and they are also known as NSOs. Okay, nitrogen, they're just taking N from nitrogen, S from sulfur, K, O from oxygen, NSOs. Okay, you also have metals like iron, nickel, vanadium, mercury. Is mercury good for health? Not good, huh? Is sulfur good for health? Not good, so. Okay? So, you have salts like NaCl. Okay, anyway, I just given you how a compound with S looks like. Okay, this is ethyl mercaptan. Okay, or dimethyl sulfide. Okay, and this is pyridine. It's got a nitrogen compound. Okay. So typical composition of a crude oil, you have 80 to 87% carbon, 12 to 15% hydrogen. Sulfur is between 1 to 3%. Okay. Nitrogen is greater than 1, less than 1. Oxygen is less than 1. Metals less than 1. And salts also less than 1. Okay. But this is just typical. So if the numbers slightly change, don't come to me and say, David, how come the numbers are not matching mine? Okay, this is just typical. Okay? So, crude oils, right? You need to classify crude oils. Like even when you have coffees, right? You have different types of coffees. You got cafe, latte, cappuccino, all this. So crude oil also you need to classify. Okay? So, oops. Okay. So you have how do you classify crude oils? One way of classifying crude oils is API gravity. Okay? Another way of classifying crude oils is sulfur content. Okay? Another way of classifying crude oils is by composition. Okay? How much of carbon it has, how much hydrogen it has, and so on. Okay? Now, why is it very important? Okay, if I want to refine crude oil, okay, the refiners are going to take the crude oil, right? He needs to know what type of crude oil it is. Okay, because if he doesn't know what type of crude oil it is, okay, he can't set his system, his refinery, to meet that crude oil. Okay, so it's not like you can refine any crude oil. Huh? Okay, you refine specific crude oils. Refineries are set to do certain crude oils. Okay, so what Malaysia does, they sell all our best crude oil to someone else, and we buy crude oil from Saudi Arabia, okay, and then we distill it. Saudi Arabian crude sometimes have high sulfur. Okay, so the refinery is then set up to do high sulfur crudes. Okay, product yield. Point number 2 and 3 are connected. Okay, so product yield is how much of gasoline you're going to get, how much of kerosene you're going to get, how much diesel you're going to get, how much gas oil you're going to get. The more important ones are gasoline, kerosene, and diesel. Okay, so if you know how much it is, okay, you can then get a sense of the market value. Okay, and then of course transportation and storage. Because transportation doesn't mean only in tankers and so on. It also can mean in pipelines. Okay, so if the crude behaves in a certain way, okay, we need to know so that we can take mitigation actions to make sure there's no issue when we transport the oil. Okay, storage is the same thing. Okay, example, huh? Okay, you have crude oils that are very waxy. Okay, now if the crude oil is very waxy, the pour point of the crude oil is very high. Pour point is when it starts to flow. It first flows. Okay, so if your seabed temperature, example, is 21 degrees C, okay, and the pour point of the crude is say 45 degrees C, are you going to face a problem? You're going to face a problem. Okay, the crude will solidify. So therefore, you need to take actions. One of the things that you can take action is you add an additive, a chemical additive, which is usually called a pour point reductant. Okay, or you can heat the pipeline. Okay, so you need to take some actions. Okay, and of course, environmental impact. Okay, we have things like H2S, we have things like mercury, okay, we have things like metals, okay, which are not advisable to be just disposed in any way, okay. So you want to know those that information. The two main ones are H2S and mercury, okay. So API gravity, how do you calculate API gravity? That's the equation. Okay, it's a simple equation. 141 divided by SG minus 131.5. Okay, so what is SG? What is specific gravity? Can you explain to me what specific gravity is? Yeah. She's partly right, yes, but there's some more information. What is specific gravity? Another word for specific gravity is relative density. Okay? So the gentleman behind there is smiling. Does he know what relative density is?
Yes.
Okay, what is relative density?
Against water and so on.
Yes. So specific gravity or relative density, okay, is basically the density of oil at a certain temperature, okay, at T degrees C, okay, degrees C, divided by density of water at T degrees C. Okay? So when you have Hg at 60 degrees there, it means the T is 60 degrees there. Okay? Now, what happens if you have relative density at 15.4 degrees C? What does it mean? What do you mean? What do you mean by it? Relative density at 15/4 degrees C.
The temperature of what? Oil different.
Yes. So basically here, you are comparing the density of oil at 15 degrees C versus the density of water at 4 degrees C. Okay? So why take 4? Any idea?
Water is starting to freeze.
No, there's another reason. Okay, why don't you just Google the density of water at 4 degrees C?
Highest density.
Oh,
Highest.
Why is it?
1,000 kilograms.
So it's close to 1. It's 1.
One.
Unity. So easy.
Exactly one.
Exactly 1. Okay, so that's why they use it. Okay, now, so how do you use API to classify an oil? Okay, light oils is greater than 31.1 degrees. It's a unitless number, no units, because you're dividing density against density, so that's for no units. Okay, so light oils is greater than 31.1. Medium oils is between 22.3 to 31 degrees. Okay. Heavy oils is less than 22.3, okay, and non-fluid oils is less than 10. Okay, this is coming from API. Okay, I didn't make these classifications. Okay, API says it. Okay, so just now, remember all those this thing, colors there? You can see the colors. Okay, so the heavier, the darker it is. Lighter, more likely it is. Lighter in color, it's more likely lighter. Not always, sometimes, not always. Okay? Okay, so another component classifying a crude is sour and sweet. Okay? And that basically indicates the sulfur content in the crude oil. Okay? A sour crude is something that has sulfur in it. Okay, H2S. Okay? A sweet crude is something that doesn't have sulfur. Okay? So, how do you classify a sweet or sour? It's 0.5 mass percent. Okay? And if you go to the New York Mercantile Exchange, they say 0.42.
This also determines the price of the crude.
Yes.
Like how our crudes are rated.
Yes. Okay? Because what happens is sulfur, high sulfur, it does deactivate the refinery catalyst. That's a major issue. Other issue is, of course, environmental. Okay, so the higher the sulfur content is, the lower the market value. Okay, another one is hydrocarbon composition. Okay, if the oil contains a lot of lights, it's considered either a gas condensate or volatile oil. If an oil contains a lot of heavies, then it's considered a black oil. Okay. Now, these numbers for GOR are just estimates. Don't take it as what you call confirmed numbers. Okay. And GOR basically is the measurement to quantify the amount of natural gas that comes out of solution per unit volume of oil. Okay? It's a standard thing that is used in the oil and gas industry. Okay? Now, these are typical properties of crude oil. Okay? And how they behave. Okay? If the API is high, the density is low. Okay? So they are opposites. The higher the API, the lower the density. Okay? The lower the API, the higher the density. Okay? So, what's the typical density for a light oil? Okay? Density is low, sulfur content usually is low, but not necessarily. Sometimes it's low. Viscosity is low. Color is usually light oil, light yellow or light brown. Okay, and the C20 plus. Okay, C20 plus is indication of how much hydrocarbons above C20 is. Okay, it's minimal C20. Okay, medium oils, somewhat similar except the density is moderate. The sulfur content can be variable. Okay, viscosity is moderate, not so low. Okay, it's usually brown to dark brown, and it can have high C20 plus, it can have low C20 plus. Okay, and then of course the same thing with heavy and then non-fluid. Don't forget sweet and sour. Okay, it's whether it's got low sulfur content or high sulfur content. Okay.
So sometimes when we see the composition of the crudes, right, there are sometimes where there is a certain portion of the crude where, say, example, C10 to C15 or C20, which is not really significant as how it's supposed to be. Is that biodegradable or something like
Yes.
that? So you see a lot of losses in the composition of the crude, right?
Yes. So biodegraded crude is usually under heavy,
Okay, so it's
considered heavy. The density of biodegraded oil is usually 0.89, 0.9, very heavy. Okay. So these are basically some of the crude oils that you will encounter in the world. That's why our Malaysian surface is very good oil, highest quality. Okay, Brent is secure. Okay, and then the other one that is this very often you see is WTI.
We produce high quality oil, but mostly we export it, right?
Yes. Okay. Yes. Okay. So, which are the two oils that we normally see in like when you open the TV, right? You go to CNBC. Okay. They'll always quote two oils, two names. What are the two names?
Right.
Okay. Those who've got oil and gas in studying history don't answer. Okay. So, which one are the two ones?
Reference.
If you get the answer correct, I'll treat you to coffee. Yes. Which are the two words? I'll give you a clue. One starts with B, another one starts with W. Okay, how about you? No. I'm giving you a clue. W and B. So which one out here got B? B, yeah. B. B. Yes, Brent. Which one got W? Yes. WTI. So if you go to CNBC or any this thing, you'll always have Brent in WTI. It's always there.
So what does that mean? Does that mean that we use market value for gas as reference, and then that's how we price for?
That's basically the reference price for Brent in WTI. Lah. But of course, if we are selling tapis, we will not sell it based on that one. Lah. It's just it's a market price. Okay. Okay, so the source is coming from US energy. Yeah? Okay. Okay, so any questions?
I got one.
Yes, go ahead.
So if we were to have, say, example now in our case, tapis,
Yeah.
tapis crude, and I'm producing from, say, 3 different other locations, and I flow it through and blend it with tapis crude. Does that make my crude tapis crude?
No. Should be.
So I cannot label it as tapis crude anymore, right? It becomes
It's a commingled crude.
value-wise also, it's not the same, right?
But generally speaking, I think most of the crudes that are close to tapis are all light crudes, right?
Yes, correct.
Okay, the only exception maybe is Panarella.
Which is the thicker, yeah.
Yeah, but I think the amount that is mixed into is probably low. I'm not certain, but
There's a blending factor.
yeah, that's what I think. Okay, in real life, they commingle crudes. Okay, they will always commingle crudes. Okay. Yes. Any more questions? No questions?
Wanted to ask it.
Okay, so since we got extra time, okay, maybe we'll spend some time for your thing, okay, knowledge, okay. Remember, you said that you're not sure about this, right? Okay. So, although this is not straight, it is considered straight because they're all in one line. Okay? So this is called normal arcade. Okay? This is normal arcade. Okay. If you attach this to here, it's not a straight line anymore. Okay? That's a branch. So that's why they call it a branch arcade. Okay? Or another word they use is iso arcade. Now, if I took one of this and put this, they're not easy to take out.
Wanted that.
Got that very well. Okay? Now, is this a straight hydrocarbon or not? It's a straight hydrocarbon, right? There's no branches. Okay? So just now, without this was pentane, because pentane is 5.
Yeah.
Okay? Pent. Okay? And this is hexane, 6. Okay? So you know how to differentiate between what's a branch compound and normal compound. Okay? Now, for this one, it's a ring. You can see, you can put your finger through, right? Okay? So this is a ring. So that's why it's called a cycle. Okay? So anything that you see with cycle means it's a ring compound. Okay? It's wrong.
Cycle.
Yes. Okay, so it can be 6, it can be 5, it can be even 4 is very unlikely. Okay, it's not stable. Okay, so 5, 6, 7, 8 you have. Okay. Okay. So since do you have any more questions?
So you mentioned ISO. How about NEO?
Neo.
That's the example. It's pentane. How?
Okay, neopentane is basically
Seven isomer, right? So it's
so he's talking about the isomers of pentane. You know what the isomer is? Okay, so it's got the same molecular formula, okay, but its structure is slightly different. Okay, so if you in pentane, okay, for pentane, that means pentane means 5 carbon. Okay, you can have okay, so this is a straight chain. It's called N-pentane. Okay? Then you have okay, this is called isopentane. Okay? And neopentane is
okay.
okay. Now
The structure.
the structure is different. Okay, so these are still branched alkanes. It's just that this is a pin in the oil and gas industry. They always use neopentane.
So, because when you study, we never use any new.
These names are all basically created for the oil and gas industry. Okay, so if you what do you call study chemistry, basically this is the thing. Okay, what is this? This is now what do you call IUPAC name is what?
1, 2, 3,
Ah,
You won't call it as 3. You'll just say little bit because even if this
But
one
if the carbon attached to that,
But you just transform it the other way, it's still 2 and 3 is the same one. Okay, so you call it methyl butane. Okay, so this one is pentane. This will be methyl butane. Okay, and what about this?
Diamond. Dimethyl propane. Now we call it mother chemistry.
No, but it's okay, because basically clear out the air.
So unfortunately, the oil and gas industry likes to do things separately. Okay,
Not for him.
so you see, chemists will talk about density, they talk about integral. Okay, so we will normally name it pentane, they will call it pentane. Okay, we will call it methyl butane, they will call it isopentane.
But it's two of the same line.
It's the same. We call it dimethyl propane. Okay, they call it neopentane. Okay, I'm sure you're in the vertical palm oil industry. Palm oil industry. Palm oil industry also have their special names, right? So typical. Okay, everybody likes to have their own names.
Then when it comes to biodiesel, I think I don't know, they have the same similar.
Okay. Any other questions?
What is the worst crude in your experience that you've seen, which is hardest to flow through a pipeline?
Waxy cruise.
Example, in Malaysia, do we have any fields of such?
I don't think so. I can mention the names.
But I'm sure there is, right?
Yeah.
It waxes in the pipelines.
Yes.
Others-
We had to deal with crude oil at 45 degrees C.
Oh, that's what you mentioned. Right?
Yes.
So it exists. Actually,
There are crude oils at very high point. Remember, our point is the point at which it first flows. Okay, so imagine in general, okay, shallow waters, you've got deep water and shallow water. Shallow water, the normal seabed temperature is about 21 degrees C.
we have
Okay, deep water is about 5 degrees C. Okay, if 45 in deep water, they're on sure case 45. But 21 degrees C or so, it's solidified. So to stop this from solidifying, what you will do? You add chemicals, they call it 4-point depressants, PPD, or they will use wax lasers. Okay?
PPDs and wax inhibitor, what are the difference wait, it's the same thing, right? If I understand.
No. One acts differently, another acts differently.
So one protects, reduces the point, which I understand, point depressant. The wax inhibitor, how does that? I mean, does it do something different?
The 4-point depressant, they act differently chemically. The way they act is they act in a different way. One stops it from agglomerating, means
Bonding together.
yes. Essentially nowadays most chemical companies, what they do is when they use a chemical, it contains both. So they're not exactly 4-point depressant, they are also
Compost.
compost. Yeah.
But those days used to sell like try to sell you both, you see, so they make money from it, they make money from there. So they like to sell everything, you know.
Okay. So you need to reduce this. If you don't reduce this, it will.
Is it the temperature of the product?
The temperature of crude oil will vary. Okay, so when you have a facility, you're going into facilities of oil and gas, see, right? Okay, so I think that one is a bit difficult to see, but basically from the facility, you go into the pipeline. Okay, usually once it goes into the pipeline, right, it's usually hot. When it exits the facility, it's usually very hot. Okay, as it enters into the pipeline, okay, the seabed temperature is very high. The pipeline is the oil is hot.
If let's say it's very hot, it can
It will flow for a while, okay, but then as the temperature becomes cooler, the oil will become cooler because the surrounding is cool, right? So as it becomes cooler, okay, the oil will start to solidify. Okay, so
Pipelines are long pipelines, so it's not 10 meters.
they're not like 1 to 100 meters. It's like
Hundreds of kilometers.
sometimes hundreds of kilometers.
And that temperature we are referring to Malaysian waters, right?
Yes.
It's not sea or something.
Not sea or reverse.
Yeah, I think that-
Not sea or reverse. I mean, recently they were saying that you all know about the current war that's happening, right? Okay, so now they can't flow oil, they can't flow gas and oil from Russia to Europe. So they have to take the other route, okay, which is through the Arctic and then going down there. Okay, so Arctic oil is very cold. Okay, so it depends on what kind of oil you're dealing with. Some oils, oil is very low, so okay. Okay, but Malaysian oils tend to be a bit paraphilic, so they tend to be a bit waxy. Okay, the term is waxy, wax. Okay, waxy. Okay, so it's like, have you seen a candle? Okay, that's how a wax looks like. Okay, so it can solidify. Once it solidifies, you got a problem. Okay, so you can use PPDs, wax inhibitors. You can also use what you call insulation.
Oh, heating.
Insulation, you insulate the pipeline, so that means the heat loss is slower. Okay, you can also use heating.
In terms of insulation, when we say heating, right? So there are times where we use steam. There are times where we actually use steam and then we run it through on the outer layer of the pipeline. There are also times where we use heat mesh, right?
Yep.
Which is basically just heating the lines. And then, of course, requires a lot of energy as well.
Of course. Heating is the last option you'll take, because a lot of energy is required. Very expensive. Okay.
It's difficult to do. So
One wire snaps the whole thing.
So, any other questions? Anybody from the? No questions. Okay, so I guess then we can end the thing. Okay. What is something? Okay. So,
it's invested on.
so anyway, just now we did some, but you know already that it's coffee, right?
Just thinking.